Good afternoon, everyone. This is Laura McDermott speaking on behalf of the Northeast SARE funded Soil Management and Berry Crops as a Model for Management Education project. This is the 12th webinar in a series of 12, the final webinar, so I really am happy that we've got a good group, and thank you for logging on. I think most of you know your way around this Adobe Connect classroom. You put a chat in that long, narrow box right in the lower center. That's how you communicate. There are web links here for the webinar archives in case you've missed any, and to Northeast SARE. And then just on the, apparently, according to Kathy, there are a couple of folks that have not finished the Northeast SARE demographics questionnaire. We would really love everybody to do that. It's something that we need to have done for the grant. And I do, there's going to be more information about this, but this is concluding the first year of this project. The webinars are part of a 2-year Northeast SARE professional development project. And we'll have more information about the second year's work at the end of this presentation. And then Kathy Heidenreich will also discuss the post-test and the webinar evaluation that we'd like everyone to complete at your leisure. So without further ado, I think we'll move into the second phase, the last educational presentation of the webinar series. Dr. Harold Van Ness will be giving. Harold is the Professor of Soil and Water Management and Chair of the Department of Crop and Soil Sciences at Cornell University. His current research and extension interests are in precision management of nitrogen, soil health, and space-time statistics. And today he's going to be speaking about soil management using ecological principles and soil health management. All right, Harold, thank you.
Thank you, Laura. I hope you can all hear me. Good day. So in this final webinar, I'd like to kind of bring together some of the management approaches that we've discussed in the past months, and perhaps think about it a little bit more at a conceptual level, especially how we can bring ecological principles into sustainable berry management. So a little bit about agroecology. Miguel Altieri defined it as the application of ecological science to the study, design, and management of sustainable agroecosystems. Ecology, of course, relates to how organisms interact with their environment, and even though agricultural systems, almost by definition, are not natural systems, there's a lot we can learn from natural systems, and that's also applicable to agricultural system. It can enhance the agricultural systems by basically mimicking some of the natural processes, especially how various organisms interact. So this could be soil organisms like worms or fungi or bacteria. It could be plants, either our berry plants, which we're primarily concerned about, or other plants that might interact with them, like maybe cover crops or mulch or something like that. The idea is that it encourages beneficial biological interactions, synergies, and efficiencies, that it recycles nutrients, energy, and carbon in favor of external inputs where possible, and that it kind of approaches multiple tactics. So with this latter point, we mean that we tend to bring in a lot of external inputs into agricultural systems, and most of the time that's necessary to have the production potential that we're looking for, but there's a lot of internal cycling that we can take advantage of. And really it's a framework for approaching agricultural management that is really much more knowledge intensive. And in a way, I think that's been the purpose of this seminar, where we discussed a lot of approaches that are not simple, and there's often not very easy prescriptive recipe type answers, but that need to bring in basically our knowledge of the system and how the interactions within the system occur. So this graph here shows 5 legs of a table that represents natural ecosystems, and these are basically represent 5 characteristics of natural ecosystems. They tend to be self-regulating, they tend to be efficient, they are diverse, they are generally self-sufficient, and they are resilient. So let's look at those in a little bit more detail. So when we think about a natural ecosystem, you have to keep in mind that these systems have evolved over the years, and basically have come up with what you might want to call a successful formula. So they have to be efficient in terms of energy, in terms of nutrients, water, and carbon, and they tend to cycle quite efficiently within a natural ecosystem. There's typically very little waste, because one organism's waste is another's resource. In agricultural systems, we often have a lot more waste and external losses, like, for example, nitrate leaching or runoff, that would be wasteful in a natural environment, and we have to minimize those in a more managed environment. They tend to be diverse. Above and below ground biological activity or diversity leads to checks and balances. If we think about soil organisms, we have beneficial ones, we have pathogenic organisms, and they tend to keep each other in check. Above ground, we have different plant organisms that also impact and compete with each other, and basically provide a balance there. They tend to be self-sufficient. The only external inputs tend to be sunlight, rain, and air, and not many of these other external inputs that we normally see in agricultural systems. So they evolved basically to be efficient and to basically take advantage of the limited resources that they have available. They are self-regulating. They have diverse ecological communities, and severe disease or pest outbreaks tend to be uncommon, again because of this diversity and keeping the checks and balances. Their populations tend to be dynamic and continuously in flux. And last but not least, they tend to be resilient. Many natural systems have been subjected to extreme events, whether it may be extreme precipitation like a hurricane, or extreme cold, or extreme dryness, and that way they've basically adapted to those kind of environments, and they've built resiliency into their ecosystems. They can be damaged, but they tend to come back more easily than a damaged ecosystem. So the question then is, which of these can we achieve in agriculture? And I think we have to be realistic that agriculture, by its very design, is not natural, because we basically try to favor one plant, or berry crop in this case, over other plants, but we can still take advantage of a lot of the principles of natural ecosystems. So let's try to maybe contrast that a little bit to sort of the more conventional agricultural approach, and how many of us have learned about managing agricultural systems. The most dominant paradigm in agriculture is more reactive management, short-term response to immediate problems that relies on external interventions. And we have some examples here. For example, if you're low on nitrogen, then you apply nitrogen fertilizer. If you have an insect problem, then you apply an insecticide. If you have weedy conditions, you apply an herbicide. If the soil is dry, you irrigate. If the soil is compacted, you use a subsoiler or something like that. Now, sometimes these problems can be symptoms of deeper or more fundamental problems, maybe a poorly managed ecosystem. And this also tends to be a relatively short-term approach to things. We might think of, in tilled systems, we might think of tillage that way as well, that we have a short-term benefit from tillage, but in the longer term, we do damage to the land. Now, to contrast that, a more agroecological approach is more proactive and looks more at the long term. And the idea here is to develop internal strength into the system that allows it to be more efficient, more resilient, and all those qualities that we'd like to see in good agroecosystems. So we'd like to use strategies that enhance mutualism and synergies. Many of the, for example, of the soil biota can enhance plant growth. Mycorrhizae are one example of that. We'd like to be able to stress the pest and enhance the beneficials, and create soil and above ground conditions that promote growth of healthy crops with enhanced defenses. And the analogy that I often use when I talk to students or stakeholders is the analogy with human health, which we've used before. And when you think about proactive long-term management, it's the analogy would be to basically live a healthy lifestyle, to eat healthy, say a high fiber diet with fruits and vegetables, not too much meat, to exercise and basically live a lifestyle that's low of stress. That basically gives you internal strength and health in your body. The contrast there in terms of the more reactive management would be more like getting sick, or say getting a bacterial infection and taking antibiotics. And there's nothing wrong with that. It's good to do that at the time. But what you'd also like to do is you'd like to be able to build that strength into the system over the long term. So when you think about the human health, eating a healthy meal, eating a salad or eating some fruits and vegetables or some high fiber breakfast doesn't overnight make you into a healthy person. You need to have a long-term commitment to good diet and exercise to become healthy and to build the strength in your body to be able to withstand a diversity of conditions. So the analogy is really very similar. And you want to focus on at least having a long-term strategy in managing your ecosystem, your agroecosystem, to reduce the susceptibility to stress and build resiliency and strength in the system. So that's basically captured in this graph that you can see here. And there's basically three components. The first is this long-term preventive management. The second is a little bit more shorter term, sort of seasonal management. And then the third one is the real short-term reactive management. And so if we look at start with the preventive management, we can think of sort of an above ground component and a below ground component. So let's start with the latter. If we think about building healthy soils, these are some of the management practices that we discussed earlier. Start out with assessing your soil. Try to improve the soil even before you plant your berries. Make sure that the pH is corrected. Add organic matter to build up the carbon levels in the soils. Reduce compaction problems. All those kind of things that are sort of preventative, longer-term management approaches. When we think about above ground, good crop selection. Select varieties that are resistant to certain diseases. Make sure that they are planted well. Things like that basically will enhance the success of your plant. So this then will create soil and above ground conditions for healthy plants with enhanced defenses. So a second level then, you might think of sort of in-season management. And this is more sort of planned in-season management. Think in terms of integrated pest management. So you commit to a set of practices that help you better manage pests in your crops. For example, you commit to weekly field inspections and scouting. That you could look for diseases, you could look for insects, you could also do some soil measurements. You can maybe keep track of the nitrate levels. You can do tissue testing, things like that. That on a regular basis is a commitment to monitoring your crop. And then finally, you may need to do some reactive management. You may need to apply a pesticide, whether it's organic or inorganic. You may need to correct some nutrient problems. And so this is sort of the immediate response. Again, going back to the human health, that's more like taking some antibiotics or taking some cold medicine so that you, on the short term, can reduce the impact. So in a way, what we have here is a range of management approaches that we have to use to optimize our crop. What we need to keep in mind is that we have tended to focus more on the reactive management, but we need to make sure that we plan ahead of time, starting with site identification and site remediation, to also do the long-term preventative management. I just wanted to show you an example of this, and this actually relates to corn production in Kenya, but I think it's very interesting results from a study from a few years ago by Marenia and Barrett, and they are basically agriculture economists here at Cornell. And what they did is they looked at nitrogen response on lands that had a range of organic matter content or carbon content. And this is in western Kenya, where some soils have been in production for maybe 100 years, and they tend to have low organic matter contents, and other soils that have been deforested very recently, say in the last 5 or 10 years, that still have a lot of organic matter. And what they found was that when they applied fertilizer, that the response to fertilizer was much more favorable for the soils that had a higher organic matter content than the soils that had a very low organic matter content. And this line here is actually the price of the fertilizer, which is 200 Kenyan shillings in this case per kilogram. And so the soils that were very degraded and very low in organic matter didn't actually even have provide a profit to the nitrogen application. The reason being that these soils had a lot of other constraints because they were low in organic matter. So they may have had higher runoff, they maybe have had compaction problems, they may have been more droughty, and so you didn't actually get a good return on your investment, while on these better soils you did get a much higher return on your investments. So we can think similarly for other crops, that if we have a low quality soil or unhealthy soil, that we're not going to get as much return on our investments than if we have a high quality soil, because there are so many other constraints to deal with when we have a low quality soil. So here are a few other examples of ecological management. Many composts, but not all, they suppress root diseases when used in a potting mix, but they also help fight off leaf diseases. So compost, for example, can be actually quite suppressive of all kinds of disease problems, because with the compost there's a lot of beneficial organisms that help suppress the pathogenic organisms. Another example, lower early season nitrate levels decrease viability and competitiveness of weeds with small seeds, because these run out of nutrients more quickly. So systems that are very high in nitrate levels actually may enhance competition of undesirable species, in this case seeds. Another example, flea beetle pressure and damage to cabbage is more severe on compacted soil. This is some work from Dave Wolf here at Cornell that found that when we have a soil in poor health, that the insect pressure tends to be much higher, because the plant can't resist these kind of pressures as well. Another example, root rot severity of vegetable crops is decreased by growing cover crops and allowing sufficient time for them to decompose. Sometimes we refer to the term biofumigation. This is work by George Abawi in the plant pathology department at Geneva. And many cover crops suppress plant parasitic nematodes, also work from George Abawi's lab. So there's a lot of ecological principles and mutualism that we can take advantage of when we use these more agroecological approaches. And that reduces the need for these more reactive approaches, which typically means expensive inputs like pesticides and fertilizers. So that brings us back to the soil health test that Bob Schindlerbeck discussed in the past few months. Because the soil health test is really about this more proactive, long-term management approach. It's not about a quick test that allows you to respond immediately. As you may remember, we have physical, biological, and chemical indicators that we use in a test. We measure their values, and we interpret those values into a rating. So we have a way of saying, well, if the aggregate stability is 26%, is that good or is that bad? And we use the rating scale on a scale from 0 to 100. So the main idea here is then to be able to identify the constraints, which are indicated in red here, and to be able to address these constraints, especially through more long-term sustainable management practices. So the soil health test basically is a guide to longer-term soil health management. When we think about berry production, we have to, as with any other crop, we have to think about how do we actually interpret those values. So the aggregate stability is 26%. Is that high or is that low? And that also depends on what kind of a crop that we're growing. Similarly, surface hardness or active carbon. So how do we actually interpret these numbers, and how do we do that for berry production in particular? So we developed these scoring curves that Bob discussed, and we have basically three categories. One is where more is better, for example, generally with organic matter or active carbon or aggregate stability. The higher the number, the better it is in terms of soil health. In other cases, we have less is better. That an example of that would, for example, be a penetrometer reading, where a high number is actually less favorable. And then we have an optimum, for example, pH might be an example of that. I think what a key point that we need to keep in mind is that we've developed the soil health test primarily for disturbed systems, for vegetables, for field crops, and that these interpretations, these scoring curves, would actually vary depending on what kind of a system we have. When we're dealing with berry systems, they tend to be less disturbed, and we might have different expectations. Another example is that some berry crops actually do better under a lower pH and others under a higher pH, and certainly that might be different than something for a typical vegetable or field crop. So one of the things we need to think about is how can we enhance and adapt these scoring functions and these interpretations to a berry production system so that we can give better management recommendations. So the way we had approached that with our initial soil health test development was to either use a frequency distribution from our database. What we did is we analyzed a lot of samples from basically very low quality soil and very high quality soil and everything in between, and then basically look at the distribution and then develop a scoring function from that. We also use expert opinion. Literature values, for example, we do know what an optimum pH is for many berry crops or for many vegetables, so we can apply that directly to our interpretation system. So again, we developed the soil health test primarily for disturbed systems, vegetables and field crops, and they would need to be adapted to perennial systems. We may need to tweak those interpretation curves. We don't need to necessarily change the measurement methodology. We need to change how we interpret the numbers. So this just illustrates how we did that, this approach of looking at the distribution function. So if you measure a lot of these, soils from variable conditions, and you have some information on how the crops perform on those soils, then you can develop this distribution function, and you can interpret how what's basically high and what's low. And so this, for example, is for active carbon. So if you're less than 400, you're basically pretty low, and if you're greater than 800, you're pretty high. So that's how you might want to interpret those numbers. And what we did is we then basically developed these scoring curves by taking the normal distribution function and turning that into a cumulative distribution function, which is just a simple mathematical trick that you can do in Excel. And then you develop a scoring function that helps you interpret your measured value here on the x-axis and putting that into a score. And with the low scores being in the red zone and the high scores being in the green zone and the intermediate ones being in the yellow zone. So what would need to happen if we want to apply this framework to berry crops is we need to tweak some of these scoring curves to make them more applicable to berry crops in general and perhaps to specific crops, like for example pH adjustments that may be needed depending on what particular berry crops we're talking about. So here's some final thoughts then, and this is my last slide. So proactive management helps build resiliency into the cropping system. So this relates to some of the very early webinars we did where we talked about site selection, site remediation, investing in compaction remediation, adding organic matter, doing pH correction, and all those kind of things. Then secondly, we may need to do some reactive management to optimize the performance. So this may involve fertilizer application, or sometimes pest control might be needed. So both proactive and reactive management are critical. My main point is that we've tended to not put as much emphasis on the proactive management and more on the reactive management. Soil testing is an important component, and interpretations need to be refined for berry production. And I would say with soil testing, both the more conventional soil testing, which is really nutrient testing, as well as the more comprehensive testing as we do in the Cornell Soil Health Test. And of course, organic matter is a key component. This is the life in the soil, and it supports a lot of the organisms in the soil, and that's what allows for this more agroecological approach. But we should keep in mind that organic matter is not everything. We can't solve all the problems with organic matter. And that was my last slide. So at this point in time, I will turn it back to our moderator, Laura.
Thank you very much. I'm wondering if people have questions right now, if there's anything on your mind. I actually do have a question, maybe to start us off with. Those scoring functions, what volume of testing, what volume of tests do you need to be able to kind of have some level of confidence and be able to make those scoring functions work for a perennial crop like berries? Are we close to that? Do we need just a bigger volume to analyze, or how do you get there from maybe where we are, which is that we need more interpretations or more information?
Yeah, that's a good question, Laura. We don't have to reinvent the wheel for this. What is important is that we have a better understanding of what are more or less appropriate, or so let's say good levels for some indicators and not so good levels. We did some work in the past years with the grape group here at Cornell, Tim Mortensen and Leilang Cheng and Alan Laxo, to apply the soil health test to viticulture. And of course the needs are slightly different. In fact, in viticulture it's a little bit more complex because often you want the crop to be somewhat stressed. Now for most other berry crops, I don't think that's the case. So I think that the first step is to basically to look at the current scoring functions and to see what might be appropriate. For example, a very obvious change would be, what's an optimum pH level for for a particular berry crop, and that of course would vary depending on whether it's blueberries or raspberries and I admit to not being an expert in this area, but I know that much. The other thing is that because these are more perennial systems, that we may be looking for different values of, say, active carbon or organic matter. And so the best approach, I think, and in fact that's what we're planning to do as part of this grant, is to start collecting some samples from berry fields that that hopefully represent a range of conditions. So we need to make sure that we get samples from some soils that we really know are not performing very well, and we need to have some samples from soils that we know do perform very well. And so then at least we can start sort of defining the range and the boundary conditions for good versus bad soil. And then it's a matter of sitting down with some experts and then coming up with good numbers. You need to keep in mind that the numbers that you get out of a soil health test are a management guide. It provides you insights like your blood pressure or your cholesterol level for your human health. But you can't do an exact interpretation, but you can learn a lot from looking at these soil health reports that allows you to better manage your soil and your crops.
Okay, thank you. Glenn Kaler from Maine asks, are soil health tests ready for use in 2012 or still in development?
They are ready. In fact, you could submit a sample tomorrow if you wanted to. They are now we don't have particular interpretations for berry crops, but we are receiving samples and we are providing results that a professional could certainly interpret. Part of what we're trying to do as part with this grant is to help develop better interpretations for berry crops specifically.
And then Oneida County is wondering what we know about water management and its effect on berry production.
I'm not sure whether I quite understand the question, but I mean what we do know is that that both extremes are a problem. So we can have too much water, and then we need to consider drainage because excess water creates a lot of problems, denitrification, more pathogenic problems, root rot, etc. And we can also be on the other end where there may be drought stress. Now, irrigation is certainly a more reactive approach, but we can build a lot of internal strength in the system by creating a soil environment that is higher in organic matter content, because organic matter holds a lot of moisture, that allows for deep rooting, so no compacted zones, that has a correct pH throughout the profile, because roots don't do well in acid subsoils. So we can build a lot of strength in the system by basically creating a very strong and extensive rooting system.
Yes, and I just want to add to Oneida County, last week's Dr. Belinsky-Santos did talk a little bit about fertility management and water management in terms of more soil-less berry production, so maybe that would be of interest to you. And Kathy mentioned in the chat that that webinar plus some material associated with it, she is going to be posting on the website and sending a link to those of you who are on her email list, which I think is everybody. Kathy also sent out an email to folks wondering if they had any kind of unresolved questions from the berry series, and now might be a time if anybody does have those. Or Kathy, I don't know if anybody emailed you back with anything about that.
Laura, I didn't get anybody with any burning unresolved questions, but if anybody has any, it would be great to bring those out now.
Okay, wow. Oh, maybe Lee has something. There's no pressure, Lee. We're just all watching to see how quickly you type. The Adobe Connect is supposed to allow us to be able to turn on each of your, if you had a headset, we could independently allow you an opportunity to speak. We have not tried that yet, but maybe in some other setting we will try that, because this is the problem. This is the challenge, is the typing part. But thanks for your patience, everybody. So Lee's comment is about submitting multiple samples, 2 from each of 2 growers. The results were very interesting, and yeah, I agree, Lee. I think this is fascinating stuff. We've just begun working on it with vegetable growers, and I did do a couple with some berry growers in a reduced till study, and it is not, we think we know what's going on in the soil, but it is really surprising when the soil health tests come back and proves that we don't know everything about it just from, what we expect. But yeah, that's great. And Oneida County mentions that handouts and website information will be helpful, and that is true. And I'm going to take it that people are done with questions, so why don't we move into the very last portion. Thank you very much, Dr. Van Ness. Kathy Heidenreich is now going to give us a little summary and lay out the next phase of the project. So thanks a lot, Kathy.
Thanks, Laura. And I'll ask everyone to excuse me. I'm just recovering from a cold, so I sound a little bit like Donald Duck today. So what I want to do just briefly is to review the purpose of the project with you and give you an idea where we are in the timeline and where we'd like to go from here and how you might play a role in that. So the issue that has been that commercial berry growers in the Northeast traditionally make standard fertilizer applications based on crop age. And as Dr. Van Ness pointed out so aptly today, it's a reactive sort of management versus proactive. And this is in spite of the fact that for 10 years or more, we have some very good research that indicates that analysis-based fertilization programs really are more beneficial, both in terms of dollars and cents and in terms of yield and plant health, and that soil health can also have an impact. And soil health improvement techniques have also not been adapted very widely among berry growers, and so we have a concern about that. So when we started looking into why this might be so, we discovered that ag educators, the folks who've been participating in particular, are often called on to cover multiple commodities, and sometimes they're actually operating outside their field of expertise. And so it's a struggle to help berry growers with soil and nutrient management problems, and then also with interpretation of things like the Cornell soil health test results or the foliar analysis results, and that we didn't have any comprehensive resources on this to help people do that. So Dr. Marvin Pritz and the team have put together a 2-year project to help provide some training both for ag educators and for the berry growers. And so this webinar series has actually been year 1 of the plan. We can check that off now. We've worked through the 12 webinars together, and while you've been working through the webinars, we've been working on resources that you'll be able to use in grower training. And so the next phase is where we're hoping that it's your turn and that you'll assist us by providing some training to growers. And so we're going to look at that in a little more detail. So how we're going to measure the success, we're going to look at knowledge before and after participating in the project to see what sort of changes may have occurred. And then we're also going to look at adoption and success of analysis-based nutrient and soil management in years to follow after the project. So we had 72 educators when we started. We've had various numbers of educators throughout, and so we've accomplished the first goal. And the second goal, we'd like to have 15 of you who've been willing to train to actually develop and deliver an outreach program. And we're hoping that we'll get at least 10 growers at each or more at each training, and then that 50 of them will participate in a soil and nutrient management health testing. And so we have complimentary Cornell soil health tests for 50 growers. We also have complimentary foliar analysis tests for the same 50. And then we're hoping that educators who sponsor training will work one-on-one with the growers to interpret the results and to come up with some sort of a plan to implement on farm, and then that the same educators will collect feedback from the growers on how well they think it worked. So let's talk about where we're going from here. So in terms of the webinar, I do have a list of people we're missing demographics questionnaires from, and I'll be emailing them and letting them know. And there's a post-test. Remember, on the first webinar, we went through 20 questions to test your knowledge to see where you were starting from. There is a SurveyMonkey survey, and if you look in the bottom left-hand box, the Web's Links box, you'll see the post-test there, and you're able to take that. That will be open for a month in case you haven't had a chance to finish all the webinars, or you need to go back and listen to the recording of that one you missed. And then there's also an evaluation. So we're asking that each person who participated, whether you only saw one webinar or whether you went through all 12, would do both the post-test and the evaluation. And I'll be sending out an email reminder on that as well. So now it's your turn. So what we're hoping to have, well, we will have, is materials available for you to assist you with grower training. We have some web pages that are under development that are nearing completion, and you'll be able to have those available as well, and to provide input as to their utility and what may be missing or what would be useful that may not be offered there. The members of the team will be available to assist on request, and I'm going to be posting training dates on the webinar archive page so that we can try to avoid overlaps in training. Because I'm convinced, of course, that everyone will want to go out and do this. So what we'll have in terms of grower training materials is a 1-hour PowerPoint presentation that's going to discuss Cornell soil health test and the assessment, and then foliar analysis, and it can be used in a classroom or field setting. We'll have a set of grower pre- and post-test questions to go with that, maybe a short set, 5 or 10 questions, so that we can measure knowledge before and knowledge after. We'll have some sample test results for group exercises. Remember when Marvin and Eric talked about the test results and what sort of mediation would be needed, and also Robert with the soil health test. And then apart from that, in terms of your grower training, you're able to add whatever bits and pieces you might like, from playing the recorded webinars, having guest speakers covering other topics. Really, you can cater it to the needs of your growers. So once your training is complete, we're going to ask you to select some participating growers to participate in the soil health test and the foliar analysis. And then we're going to have a standard operating procedure that we'll make available to you and them, which will discuss how they might implement at least 1 or 2 of the practices on their farm on a portion of their crop. And then we would also ask them to participate in an exit interview to share their insights on the crop health and performance of the new practices that they've implemented versus their standard practice. And so you'll be hearing from me in the next couple of weeks. We hope many of you will be interested in participating, and we want to thank you very much for being a part of the webinar series.
All right, thank you, Kathy. There is a couple of questions, or at least Lee has a question about funding to support the outreach program.
Lee, we didn't have that in the budget for the project. We specifically were interested in building the numbers of soil health tests we had to go into the database so that we could start working on those recommendations. So we focused the funds in that area.
Okay, and we can put your email. We can put the email right here in the chat box if you'd like, Mark. And so the links are there for the Educator PostTest. If you're ready to take that now, certainly you could do the webinar series evaluation probably, because you don't need to listen to all of them in order to complete that. But we do hope to hear from all of you. I think this is a rather exciting way to get training out to a large amount of people. So I hope everyone is able to take advantage of it. And if you have any other questions, please. Okay, so there are a couple more questions. Is the outreach program targeted only to Northeast states? Bob wonders.
Bob, that's a good question, and it's not necessarily only Northeast states. That's the primary focus of Northeast SARE, but we really are interested in getting 50 growers lined up, and so once I have an idea of, once people have let me know who's interested in having a training, I'll have a better handle on that, and I'll be able to talk to you about that specifically. And initially, what we decided to do would be, we have 50 complementary sets of tests. Depending on how many grower trainings that we have, we're thinking about dividing them amongst the number of trainings. And so, Sharon, in terms of first come, first served basis, no, not necessarily. Educators who are hosting training, say we have 10 educators who host training, we have 50 tests, then we would have 5 tests available for each training. If we have 4 people, we could have 12 and a half for each training. So you kind of get the idea. So far we have 4 scheduled, and they're listed in the box on the right, and we're hoping to, in the next couple of weeks, to get the others scheduled, and then we'll know how many tests we have available.
And that's, if you scroll down in the notes box, there are some grower training dates in South Carroll on March 28th, Greenwich, New York on March 29th, May 9th in Waterport, New York, and May 10th in Williamson, New York. So there are some opportunities, and we will have more information about them, exact contact information and stuff in case someone would like to go and watch how it's done or just want to advertise it to your growers. But we do hope that you will go ahead, and most of you are very experienced growers or educators, so this should not be a problem, especially when you have all of the equipment to do the training with. Do we have any other questions, either about content or about the administrative kind of approach of the grant? So if not, I'm going to leave this webinar classroom open for about 15 extra minutes. Let people go to the webinar series evaluation and complete that SurveyMonkey. We really appreciate all of your time, the speaker's time, and Kathy, especially you, who is now busy trying to get the website and all the materials up together. But thank you very much, and good luck with your training, everybody.